Okay, so today we're looking at the product rule for differentiation, but we're going to start off with some notation that will be key during the advanced higher course. So given a function of x, y is a function of x, f of x, then we can differentiate the function to find the rate of change. That is what is known by differentiating. Okay, we can find the rate of change at a specific point x. So when we do that, the notation looks the following. So if we want to differentiate y, we get dy by dx. And if we differentiate the function f of x, then we get f prime of x. Now we can continue to differentiate this, provided that it's still continuous and differentiable. Then what we'll see is we will get other types of differentiation. So if I differentiate this again, I would get d squared y over dx squared, okay, and if I differentiated that function again, so f prime of x differentiated, I would have to differentiate again, so I would get f double prime of x, okay, and this continues. So if I differentiate that again, I'd get d cubed y over dx cubed equals f cubed prime of x, okay, so there's 3 primes there. At this point, we tend to stick to the numbers when it gets too high as opposed to writing lots of primes. So that 4 in there doesn't mean I'm substituting 4 into the value of this function, it means it's been differentiated 4 times. Okay, and the general rule, or the general way to write this would be for any letter, or any number n, then it'd be d to the power ny over dx to the power n, and that would be the function f differentiated n times. Okay, that's what that means, being differentiated n times. So that will be important for us during the course. So I'm going to start off with the product rule. So the product rule is used when we are asked to differentiate a function of x that is a combination of 2 or more functions. Okay, so an example, if we let y equal this function here, so they're both functions of x, but it's a function u multiplying a function v. Okay, so we've got 2 functions here. How do we differentiate this? Well, the rule for differentiating this, the product rule, it's to differentiate y, it'd be dy by dx. Okay, and what we do to differentiate this, it would be our function u multiplied by the function v differentiated, okay, plus the function v multiplied by the u function differentiated. Okay, so we get u dv by dx plus v du by dx. Okay, so it's very important, that's a rule you're going to have to remember. A quicker way to write this, okay, an alternative way to write this, okay, so I want to write dy by dx, then it'll be u multiplied by v prime, so v differentiated, plus v multiplied by u prime, okay, so it's uv prime plus vu prime. Okay, so that's just a other way to write it. The two formulas are the exact same, okay, just different notation. Okay, at the start I would encourage you to use this function to get really familiar with it, but once you get familiar, you'll likely quicken it up by using this formula here. Okay, so let's just jump straight into examples to see how this works, okay, so we can familiarise ourselves with spotting when it's a function of 2 functions and how to use this formula. Okay, so example 1. So I've got my formula at the top just to remind me there. It's a good idea if you want to do that as well. Always write at the top of your page so you don't have to go searching for it. But we're going to look at this function here. So y equals x cubed sine x. Okay, so this is a function, okay, x cubed sine x, but you can see it can be split into 2 separate functions, okay? X cubed, that'd be like our u, and our sine x would be our v. Okay, so you can see I'm going to write that down there. U is x cubed and v is sine x. Before my formula, I need to differentiate both of these to get part of my formula, so that's what I'm going to do first. So if I differentiate them one at a time, if I differentiate x cubed, I'm going to get 3x squared. If I differentiate sine x, I'm going to get cos x there. Okay, so now I've got my du by dx and my dv by dx. So now I'm just going to write down my formula again and then substitute in the values that I've got over here, okay, or the functions that I've got over here, I should say. So I'm going to start off with u multiplied by dv by dx. Okay, so u is x cubed multiplied by dv by x, which is cos x. That's going to be x cubed cos x. And v multiplied by du by dx, well, v is sine x multiplied by 3x squared. It's probably better to put this first, okay, so that'll be 3x squared sine x. So that's what I get given there, okay, so again, just remembering that was my u, which was x cubed multiplied by dv by dx, which was cos x. I get x cubed cos x plus v multiplied by du by dx, which is 3x squared sine x. Okay, now we could leave it at that, however we might need this further on in a question if it was asking us, so it's better to always take a common factor out if we can to try and simplify it. We can take out a common factor of x squared, and dy by dx looks like this here, x squared with a bracket x cos x plus 3 sine x. Okay, so that would be that function there differentiated, and its final answer would look like that. Okay, so you can see it's a formula that works, gets us our answer, okay, and hopefully not too many steps. The major step would be just tidying up our expression to make it suit us. Okay, we'll look at a second example now. Okay, so let me just scroll down. So we're now going to look at this example here. So you can see again, I've got a function of x, y is a function of x, but you can see it can be split up into two parts and thought differently. Okay, so y equals x to the power 6, that'll be like my u, that'll be my first function I'm going to think of, multiplying x squared plus 1 to the power 4. So that is my second function there. So that's my u, x to the power 6, and v is x squared plus 1 to the power 4. So if I differentiate them, because I'm not going to have to use the differentials of both of them in my formula, okay, if I differentiate x to the power 6, I'm going to get 6x to the power 5. If I differentiate my v, I'm going to get, well, the 4 would come down using the chain rule, so it would be 4 bracket x squared plus 1 to the power 3, but I need to remember to multiply by the differential in here. The differential here would be 2x, so I'll differentiate that there. So the 4 would multiply by the 2x, so I'm going to get 8x bracket x squared plus 1 to the power 3. Okay, so again, I'm going to follow my formula now, substitute my values in here. So the u, which is x to the power 6, will go with my dv by dx, which is this function here, and my v, which is this function here, will multiply this function here. Okay, I'm going to substitute that in. So we get that as my next line of working. Okay, u multiplied by dv by x, which will give me 8x to the power 7 bracket x squared plus 1 to the power 3. Okay, so that's where this comes from here. This multiplied by that will give me 6x to the power 5 bracket x squared plus 1 to the power 4. Again, that would be my final answer, but if we can always try and simplify. Okay, common factors, well, the good thing is, and you might be able to see it first, I can take a common factor of x squared plus 1 to the power 3 out. Okay, that's got 3 lots of this bracket, this has 4, so I can take 3 lots of that out. I can also look here to see if I can take any of this out, okay, common factor wise, and I can take 2x to the power 5 out. Okay, so I'm going to take 2x to the power 5, x squared plus 1 to the power 3 out, leaving me on this side. Okay, if I took 2x to the power 5, x squared plus 1 to the power 3 out of here, this would all be taken away. This would leave me with 4x squared, so I'm going to get 4x squared there. If I took 2x to the power 5, x squared plus 1 to the power 3 out of this, well, I'm going to have one bracket of this left, so that's my bracket there. And if I took 2x to the power 5 out of this, I'm left with 3 there, so that's 3 bracket x squared plus 1. Okay, what we can do is we can now work within this bracket here, multiply this bracket out, and tidy up my answer. So my final answer for my question, okay, y equals x squared plus, this y equals x squared, sorry, x to the power 6 bracket x squared plus 1 to the power 4 would be dy by dx equals 2x to the power 5, open bracket, x squared plus 1 to the power 3, with another bracket, 7x squared plus 3. Okay, so you can see these functions do get quite messy and quite big, okay, but we can always try and tidy up to suit us, okay, because we might need to use this for another part of our question. We'll look at an example that does this. Okay, so a skill from higher, okay, so we want to find the equation of the tangent, but we're given this function now, y equals x multiplied by the square root of x plus 1. We want to do this when x equals 3. So you can see this would be a higher question, but it's now advanced higher level due to the function we've got here. Okay, so y equals x multiplied by the root of x to plus 1. I'm going to let u equal x, and I'm going to let v equal the square root of x plus 1. Okay, which I've got here, but I'm going to have to differentiate both of these. U equals x is fine, but I'm going to rewrite this in the form x plus 1 to the power of half, which will make it easier to differentiate. So differentiating both of them first. Okay, well, x just becomes 1, so my u prime is 1. I'm going to use prime notation for this just to show you how it would work. This here, if I differentiated that, okay, half would come down, then the power on the top, you take 1 off, which would be negative a half, but I can rewrite that as 1 over 2 multiplied by the square root of x plus 1. Okay, so this is what my v prime would look like. Now, not changing the formula, but just rewriting it using prime notation, okay? The formula would look dy by dx equals u multiplied by v prime plus v multiplied by u prime. Okay, so let's do that just now. So if I multiply u with v prime, well, this x is going to multiply this v prime function here, so the x will go on the top. So I'm going to get x over 2 square root x plus 1. And v multiplied by u prime, well, the good thing is u prime is 1, so it's just going to be me multiplying by v here. Okay, so I'm going to use the square root of x plus 1, which is just square root of x plus 1 there. Now we could leave it at that, but I know I'm going to have to substitute values in to find the gradient in order to get the equation of the tangent. So let's see if we can get this tidy. Okay, we might need to do a bit more work, but in order to get a nicer answer. So using algebraic fractions, let's get the same denominator. Okay, so that's my step there. I've managed to get the same denominator now. I didn't have to change this one. I had to multiply both top and bottom of this by 2 root x plus 1. Okay, so that gave it a bracket x plus 1 there with a 2 on top. And I've got the denominators the same. Multiply this out and add on the x there. I would get 3x plus 2 over 2 square root x plus 1 on the denominator. Okay, so that's what my differentiated function looks like. My job now is to use this to get my answer. So I need the equation of the tangent, which means I need to work out the coordinate I'm going to use and also what the gradient will be. So when x was free, that's what we were told, we substitute that back into our y function, which is this function here, to work out what my x coordinate would be. Okay, my y coordinate would be, sorry. So that would be 3 multiplied by square root of 4. Square root of 4 is 2, 3 times 2 is 6. So my coordinate that I need to use is 3, 6. Now let's work out what my gradient is. So my gradient will be at the point when x equals 3 is if I substitute x equals 3 into here. So let's do that just now. So my gradient, if I do this properly, I should get 11 over 4. So that's my gradient. That's my coordinate I'm going to use. Okay, this is now National 5 now. Okay. So using the equation of a line, y minus b equals m bracket x minus a, substitute my values in, so y minus 6 equals 11 over 4 bracket x minus 3. Then that will give me, if I multiply both sides by 4, the fraction disappears, so it's 4y minus 24 equals 11x minus 33. If I multiply that out by 11, and then I've got 4y equals 11x minus 9. Okay, so that would be the equation of the tangent of that function, y equals x square root x plus 1 when x was 3. Okay, so the main features from today's lesson is we are now using this rule here to work out the differential of a function that is a product of two functions of x. Okay, thank you.